Hello, welcome to the tutorial 8 and 9. Today we will review about chapter 11 until 13. So in this PowerPoint, I will try to review the problems from the example from the book and also the problems from the tutorial. So this is the example 11.1 about youu. So the demand for the computer at Best Buy is 1000 units per month. And then it has the order cost per lot $4,000 each time an order is placed, and each computer costs of $500, and the retailer has the holding cost of 20%. So we need to evaluate the number of computers that the store manager should order in each replenishment lot. Or in this problem, we should find the EOQ or economic order quantity. So EOQ is the optimal lot size that we need to order, or sometimes we can write it as Q star. The formula is here, as you can see. So from the information here, we can sum up the demand, because in the problem it is still per month and we need the demand in annual or in year. So we need to times it by 12. So 1000 times 12, and we get 12,000 units per year for the annual demand, and the order cost is $4,000 or S, and then for the cost or C is equals to $500, and the holding cost per year as a fraction of unit cost is or the h little h is 0.2. After we got all the information, we can calculate the EOQ. So just put all the numbers that we need into the formula here. So the root of 2 times the demand, that is 12,000 units per year, times the order cost, that is 4,000, divided by the fraction of holding cost, that is 0.2, times the unit cost, that is 500, and we got 980 units. So to minimize the total cost of Best Buy, the store manager should order a lot size of 980 computers for each replenishment order. And it is, if we want to analyze more, we can calculate the cycle inventory, that is the average inventory that we held due to either production or purchases in lot size that are larger than the demand. The formula is here, the Q star divided by 2. Before we already got our Q star or EOQ, that is 980. So we just need to divide it by 2, and we got 490 units. And then for the number of orders per year, or N star, the formula is the annual demand divided by the Q star, and we got 12.24 times, and actually it can be rounded up to 13. And it is for the number of orders per year, it is always rounding it to up, not below, even if the score is below 5. So as you can see here, 12.2, normally it will be round up to 12, but it is round up to 13, because it is better to have more than we have stuck out. And then for the annual ordering and holding cost, the formula is here. The annual demand divided by the Q star times the order cost plus the Q star divided by 2 times the holding cost, and we get $97,980. And then for the average flow time, the formula is Q star divided by 2 times annual demand. That is 490 divided by 12,000. You may be at first maybe confused why it is 490, because we got our Q star is 980. So it is actually the same if we put the 980 divided by 2 times 12,000, and we got 0.041 year, and then we can simplify it to the month, just the 0.041 year times 12 months, and we get 0.49 months. So we can interpret it that is each computer thus spends 0.49 months on average at Best Buy before it is sold, because it is purchased at 980 units. So actually in this problem we just need to calculate youu, but this is if you want to analyze more. And then for the example 11.2, that is the relationship between desired lot size and ordering cost. So the store manager at Best Buy would like to readjust their optimal lot size from 980 to 200. So the manager wants to evaluate how much the ordering cost per lot should be readjusted. So we write first the information. So the desired lot size is 200. Before in the previous slide it is 980, and then for the annual demand it is still 12,000 units, and for the cost also still the same, and the fraction of holding cost also still the same. So from the youu formula we can move the S, that is the ordering cost, to the left side, and we got this formula, and just input the numbers here, that is 0.2 times 500 times 200 squared by 2 divided 2 times 12,000, and we got $166.7. So the store manager at Best Buy would have to readjust the order cost per lot from previous is $4,000 to $166.7 for a lot size of 200 units to be optimal. Then we move to the problem from the tutorial. From problem 1, you can see the documents or the Microsoft Word at the Google Classroom. So there is a company named Harley. It buys the parts from 3 different suppliers, that is A, B, and C. Each supplier has its own price and demand rate. And currently, Harley orders with a different truck for each supplier. And then as part of the just-in-time policy, Harley decided to make an aggregate purchase from 3 suppliers. The trucking company charges a flat fee of $400 per truck, and charge an additional $100 per stop. Hurley estimates the storage cost at 20% of the component price. So the question is, which will further minimize costs between purchase separately and in the aggregate? So to answer this question, we need to sum up the information here. This is the unit, the part cost from each supplier. From supplier A, the cost is $5. Supplier B, the cost is $4, and supplier C, the cost is $5 per parts. And then for the demand in the problem here, it is known in per month, and we need to shift it to the annual or to year. So from the supplier A, the demand rate is 20,000 units per month. Just times to 12, and we get 240,000 per year. And then for the supplier B, the demand rate is 2,500 per month times 12, and we get 30,000 per year. And then for the supplier C, the demand is 900 units per month times 12, and we get 10,800 units per year. And then the fraction of holding cost is 20%, and the transportation cost is $400 per truck, and it also has the cost of $100 per stop. Okay, so when we want to decide whether we purchase separately or aggregately, we need to compute the total cost for each option, and then we compare it. So this is from the information from the previous slide, and then we can get that the ordering cost, or S, is equal to $500 for each supplier, because we want to use one truck for each supplier, and for each stop it have the cost for $100. So it is just 400 plus 100, and then we get the ordering cost is $500. Okay, so we have to compute the total cost from each supplier, but before we get the total cost, we need to compute the Q star or the EOQ first. So for the supplier A, the Q star, as you can see, the formula is here. So the Q star from supplier A is the root from 2 times the annual demand, 240,000, times the ordering cost, 500, divided by 20%, times the cost from supplier A, that is 5, and then we get 15,491.93, and we can round it up to 15,492. And then for the total cost, the formula is here, that is the annual material cost, that is from the cost times the annual demand plus the annual ordering cost, that is annual demand divided by Q star times the ordering cost plus the annual holding cost, that is Q star divided by 2 times the holding cost. So for the supplier A, the total cost is, as you can see here, the annual material cost is the cost from supplier A, 5, times the annual demand, 240,000, plus the annual demand divided by the Q star that we have computed before, times 500, plus the Q star divided by 2, times the holding cost, that is from the 20% times 5. And we get the total cost from supplier A is 1,215,491.93. And then for the supplier B, also the same. We compute the Q star first. The formula is the same. The only difference is the numbers in the annual demand and the cost from the supplier B. So the Q star from supplier B is 6,124. And then for the total cost from supplier B, the formula also the same. The difference is the numbers that I have colored it orange. And then we get the total cost from supplier B is 124,898.98. And then for the supplier C, also the same. The difference is the number that have colored orange. So the Q star from supplier C is 3,287, and then the total cost is 57,286.34. And then we compute the total cost of purchase separately. That is the total cost from supplier A plus total cost from supplier B plus total cost from supplier C. And we get the total cost is 1,397,677.25. And then later we will compare it to when we purchase aggregately. Okay, next we compute when we purchase aggregately. The information is still the same, but the difference here is the ordering cost. The ordering cost is $700. It is from, so when we purchase aggregately, we only use one truck for the 3 suppliers, and then this one truck must get the parts from each place of the supplier. So there is 3 stops to get all the parts. So so the ordering cost is 400 plus 3 times 100, and we get the ordering cost is $700. Also, I compute the holding cost here. That is from the fraction of holding cost, that is 20% times each cost. So from the, for example, the supplier A, the holding cost is 20% times 5, and then we get the holding cost is $1, and so on. And then we compute the purchase aggregately. So first we need to compute the ordering frequency or the N star. Okay, so the formula is as you can see in here, but since we have 3 suppliers and we want to purchase aggregately, so we need to use this formula. So N star is the root from annual demand from supplier A times the holding cost from supplier A plus the annual demand from supplier B times the holding cost from supplier B plus the annual demand from supplier C times the holding cost from supplier C divided by 2 times the ordering cost. Okay, and we got 14.01. In the beginning, I said that we always have to round it up, but since it is only point zero, I think it is okay to round it to 14. Okay, after we get the ordering frequency, we compute the youu. So for the supplier A, and for the Q star or EOQ, in this case, we use this formula, that is annual demand divided by the N star. So for the supplier A, the Q star is its annual demand, that is 240,000 divided by 14, and we get 17,142.8 units, or we can round it up to 17,143 units. And then for the total cost, we use the previous formula, but we don't have to compute the annual ordering or annual ordering cost again, because it is have been computed before in here, so we don't need to compute ordering cost for each supplier. So we just need to compute the annual material cost and the annual holding cost. So for the supplier A, the total cost is the cost 5 times the annual demand, that is 240,000, times the Q star, that is that we have computed before, 17,143 units, divided by 2, times the holding cost, that is 1, and we get the total cost is 1,208,571.5. And then next for the supplier B, also the same, but the difference is the annual demand. So for the supplier B, the EOQ is 2,143 units. And then for the total cost, the computation also the same. The difference is the cost, the demand, and the Q star and the holding cost. And then for the supplier B, we get the total cost is 120,857.2. And then for the supplier C, the Q star is 771 units. And then for the total cost from supplier C is $54,385.5. So the total cost of purchase aggregately is the total cost from supplier A plus the total cost from supplier B plus the total cost from supplier C, and we get 1,393,616. So we compare, and then we decide to choose purchase aggregately because it has lower total cost than when we purchase separately. Okay, next problem 2. So there is a company named QB Shop that sells children's toys. The products is squishy, and it has the demand of 10,000 units for every month, and QB needs to pay a fee of $100 per order, and it has a storage fee of 20%. And then the QB shop gets an offer in the form of a discount if the QB's orders a certain amount of species as in the following table. So this is the all quantity discount. So the question is, we need to count the number of species that the QB has to order. So in this problem, we also need to compute the Q star or the EOQ. And this is the information that we get from the problem, the annual demand. Because it is still in month, we need to change it to the year. So 10,000 times 12, and we get 120,000 units per year. Then for the ordering cost is $100 and the fraction of holding cost is 20%. So first we need to write the QI. So QI is the minimum units. So the minimum units to so we can get the unit price. So the Q0, the minimum unit to get the unit price of $3 is 0, and the Q1, the minimum units that we have to order to get the unit price of $2.96 is 5,000. And then if we want to get the unit price $2.92, we need to order, the minimum order is 10,000 units. Okay, so these are the three conditions. It is also in the book. So it is the condition where we compare the little q here, the QI, with the big Q or the Q star later. And then this condition will decide how much that we need to order. Is it as the amount of the little q here or the big Q or the Q star later that we will compute. So we just move to the next step. So the next steps is we count the Q star. So for the Q0, the formula is the same as before. For Q0, it is the root from 2 times the annual demand is 120,000 times the ordering cost 100 divided by 20% times 3, and we get the Q0 is 6,325, and then we compute the Q1, also the same. The only difference is the cost of the unit price, that is 2.96, and then for the and we get 6,367, and then for the Q2 also the same. The difference is the cost here. The unit cost or the unit price is $2.92, and we get the Q2 is 6,400. Okay, so when 11. We compute the Q star here, we analyze for each unit price options for how much quantity that we need to order. So we already got the Q star for each unit price, and then we need to decide which condition match for each Q star. So for the Q0, it is 6,325. So when we look up to the first condition, the little Q0 is 0, and the Q star of 0 is 6,000, and yes, it is bigger, but it is not bigger than the little Q2, that is 5,000. So it is not matched with the first condition. And then we look again with the second condition. The Q star is 6,000 and the little q of 0 is 0. So it is also not matched with the second condition. Thus, we look up to the third condition. The Q star 0 is 6,000, and then it is bigger than the little q after, that is Q1, that is 5,000 units. So it is matched with the third condition. Okay, next. And in this third condition, then we will not compute the Q0 further, and because it is not used. And then for the Q1, we look up to the first condition. The Q star 1 is 6,367, and then the little Q1 is 5,000, and yes, the Q star 1 is bigger than the little Q1, and then it is also smaller than the little q after. That is the Q2, that is 10,000. So the Q1 is matched with the first condition. So the Q star for the Q1 is, we need to order with the quantity of the big Q here, or the youu, that is 6,367. And then for the Q2, the quantity is 6,411. So we look up to the first condition. The little Q2 is 10,000, and it is bigger than the big Q2 here. So it is matched with the second condition. So for the unit price of 2.92, we need to order with the amount of the little Q2 here, that is 10,000 units. Okay, and then we compute the total cost. Since the Q0 is matched with the third condition, then it is not used, so we don't have to compute the Q0 with the unit price of $3. So the total cost for the Q1 is, here the formula the same as before. The cost, that is 2.96 times the 120,000 plus the annual demand divided by the Q star. So for the Q1, the Q star is 6,367 times 100 plus the Q star divided by 2 times the holding cost, and we get for the Q1 the total cost is 357,721.0. I'm sorry, I mean 0.4. So and then for the total cost for the Q2, the formula also the same. The difference is the cost, that is 2.92, and then the Q star. So the Q star for the Q2 is, we use the minimum units, that is the little Q2 here, that is 10,000. And then we get the total cost for the Q2 is $354,520. So we compare these two, and we choose the smaller one, and then we decide to purchase 10,000 units because it has the lower total cost. Okay, next, problem 3, still using the previous problem. If the type of discount given is the marginal quantity discount, not all quantity discount like before, then what is the amount of squishy that should be ordered by QB? So in this condition, for example, when we put an order of 7,000 units, then the first 5,000 units will be charged at cost of $3, and then the remaining 2,000 units will be charged with $2.96. Okay, and then this is the information that we got from before. Actually, it is quite the same, and the difference is the third condition here, where if the big Q is bigger than the little q after, then we put an order with the amount of the little q after. Okay, just next first in this condition we calculate the VI, that is the ordering cost of little q units. Okay, the formula is here. Okay, so for the V0, the cost is 0 because the little q0 is 0. So yeah, okay, 0. And then for the V1, it is the previous cost times the q1 minus the previous little q, that is q0, and then that is the previous cost, or the cost 0 is $3 times the little q1 is 5,000 minus the previous little q, that is 0, and then we got the V1 is 15,000. And then for the V2, we sum up the cost, the C1 times the Q2 minus Q1 plus the C0 times the little q1 minus little q0. So it is the previous cost and it is the present little q minus the previous little q. Okay, and then it is 2.96 times 10,000 minus 5,000 plus 3 times 5,000 minus 0, and we got the V2 is $29,800. Okay, and then the next step is we calculate the big Q. Okay, so for the Q0, the formula is quite different from before. The formula is here. So for Q0, it is the root of 2 times the annual demand, that is 120,000, times the ordering cost, that is 100, plus the VI, because it is Q0, then it is V0 minus little q0 times the C0 divided by 20% times the cost, that is 3, and then we got 6,325. And then for the Q1, also the same, the formula, the difference is in here in the V. So for the Q1 we use the V1, that is 15,000, and then minus the little q1 is 5,000 times the cost of the C1, that is 2.96, and we got the Q1 is 11,028. And then for the Q2, Also the same. The difference is in the fee. So the fee 2 is 29,800 minus the little Q2 that is 10,000 times the unit price that is 2.92, and we get the Q2 is 16,961. And then when we have done, we match each this big Q with the condition here. So first for the Q0, the big Q is 6,325. First we look up to the first condition. The little q is 0. And then the q after, that is q1, is 5,000. So it is not matched with the first condition. And then we look up to the second condition. And Q0 compared with little q0 is the big Q is bigger. Okay, next we look up to the third condition. That is big Q is bigger than the little q after. That is the little q1 is 5,000. And yes, it is right that the big Q0 is bigger than the little q1. Then we use the q star for this is we use the amount of the little q. The little q after that is 5,000 units. And then here for the 11,028, also the same. The 11,000 here is bigger than the little q after, that is little q2. Then the amount that we need to order with this marginal unit price is 10,000. And then for the Q2, the amount is 16,961 units. Okay, first we look up to the third condition. The third condition is the big Q is bigger than the little q after. So the big Q2 is 16,000, but we are not quite sure the little q3, so we can pass. And then look to the second condition. The second condition is wrong because for sure it is the big q3 is bigger than the little q2. And then for the first condition, actually also we are not quite sure about the little q3, but the second condition is wrong, and the third condition also we don't know, but the close as we can get is the first condition, because for sure the big q2 is bigger than the little q2. That is 16,000 is bigger than the 10,000. So for the q2 it is the first condition. So the q star for the q2 is we need to order with the amount of the big Q, that is 16,961 units. Okay, and then the next step is we calculate the total cost for each options. The formula is quite different than before. The formula is here. The annual order cost plus the annual holding cost plus the annual material cost. So we compute the three options. So first for the Q0, the total cost is here. The annual demand, that is 120,000, divided by the Q star. The Q star of the Q0 star is 5,000 times the order cost, that is 100, plus the fee 0, that is 0, plus the Q star 5,000 minus the little Q0 is 0, times the cost, that is 3 units, that is $3, and then it is times to 20% divided by 2, and then plus the annual demand divided by the Q star times the 0 plus 5,000 minus 0 times 3, and we got the total cost for Q0 is $363,900. And then for the total cost for the Q1, the formula also the same, but the difference is here the number that I colored orange. So for the Q1, the Q star is 10,000, and then the fee one is 15,000, and then the little Q1 is 5,000, and the marginal unit price is 2.96. And for the Q1, the total cost is 361,780. And then for the last, the total cost of Q2, the difference is the same, the one that I have colored orange. For Q2, the Q star is 16,961, and the fee 2 or the ordering cost is 29,800, and the little Q2 is 10,000, and the marginal unit price is 2.92, and then we got $360,365. So we compare all these three and we choose the smaller one, and then the smaller one is the $360,365. So the conclusion is QB should order with the amount of 16,961 units of species with the type of marginal quantity discount.